Hey guys, here's our review video for your systems test tomorrow. I'm just going to go through and work each problem and talk about them, so fast forward to whatever you need to see. Remember, you need to do whatever you need to do for you. If you finish it, or whatever you work on, I'm going to give you partial credit for each, extra credit for each portion that you do. So the first thing, just to remember, how to know if you're going to do substitution or elimination. Elimination is when you have both equations in standard form. And then substitution is if something is already solved for y. So for example, questions 1 and 4 would both be substitution questions because you've got an equation that says x equals or y equals. On the other side, 3 and 4 would both be elimination problems because they're both in standard form. So let's look at these problems specifically. All right, we've got question 1. It tells me what y equals, so I want to plug this in for y, which means the only thing I'm going to do is rewrite my second equation with y being different. So I'm going to say negative 6x. This is negative 1y, so I'm going to say minus 1, negative 6x minus 7 equals 4. Now that we've done that, we have parentheses, so we're going to need to distribute. That means multiply. So that's going to be negative 6x plus 6x plus 7 equals 4. Because my x's are on the same side, I'm going to combine. If they were on opposite sides, I would use opposites to move them, but since they're on the same side, we're just combining, and here negative 6 and positive 6 are going to completely cancel each other out, which means my question says 7 equals 4. Well, because there's no x value, I can't divide or anything else. I just have to think about, is this true? So 7 equals 4, is this true? Well, no, 7 does not equal 4. So because it's not true, that means I'm going to have no solution here. There is nothing I can use that will work. So this is no solution. Number 2, we said was an elimination problem because they're both in standard form. Notice that my x's are very close to being perfect opposites, but they're not. They're perfectly the same. So if we want to do opposites here, I'm going to have to multiply one of my equations by negative 1. So I'm going to do same, and this bottom one I'll multiply by negative 1. So I'm going to rewrite my equations. 5x minus 5y equals negative 15. And then negative 5x plus 8y equals positive 15. All right, my x's are going to cancel. Remember, I need to add. So 3y equals 0. And then divide. Now, you may have said, I'm actually going to back up here real quick. You may have thought, well, those cancel, these 15s cancel also. They do, so on that side, you're just left with nothing, which is 0. So then when I divide, 0 divided by 3 is 0. That's an answer. And now remember, we got to plug back in to get our second answer. Use an original equation. So I'm just going to use my original top equation up here. All right, so 5x minus 5 times 0 equals negative 15. 5x minus 0 equals negative 15. All right, that's negative 15. So I'm going to divide by 5. And x equals negative 3. Remember that you should be able to check every single answer in your calculator. The final answer we're going to write here is negative 3, 0. Question 3 here, we already said was also elimination. You can pick what you want to eliminate. I'm going to pick y's just because they're smaller numbers and they're already opposite signs. So I'm going to multiply my top equation times 5. Then I'm going to multiply my bottom equation times 4. All right, and this is what I got. So now we're going to cancel our perfect opposites, add everything that's left. So negative 52x equals negative, so that's 156. All right, divide to get x by itself. And I'm going to get x equals positive 3. And then I want to use that to plug in and find my y value. Make sure you use an original equation. Minus 4y equals negative 20. Notice that make sure you're plugging into the x spot since this is what x equals. And then we're just going to work that out, negative 24. Use opposites to move things across the equal sign. Divide. All right, and I've got y should be negative 1. So my final answer here, if I write my ordered pair, is 3, negative 1. Remember, you can use your calculator to check that answer, and you should tomorrow. On all of these elimination problems, there are many ways to do it. So if you picked other things to multiply by up here, so like maybe you didn't do times 5 times 4, maybe you did times 8 times 3, that doesn't matter. We're going to get the same answer in the end. So you don't have to do it exactly the same way I'm doing it to get the answer that I'm getting. I just wanted to throw that out there. Question 4 is again substitution because one of my equations tells me what x or y equals. This is an x equals, so I plug it in the x spot, negative 5y. And then we want to distribute. Pay attention that this 3 is only distributing to what's inside the parentheses, not to that 4y. So the 4y itself is just going to come down once you distribute. I've got variables on the same side, so we're going to combine them. Don't use opposites, just add. Now, I do have to move this 30 across the equal sign, so I'm going to use opposites to do that. And then we want to divide. So I'm going to have y as positive 3. Use an original equation to plug back in. The easiest thing to do is use where you've circled here. This says x equals negative 5y, so times 3, plus 10. That's a 10 over there. All right, so that's negative 15 plus 10. X is negative 5. So my ordered pair here is going to be negative 5, comma 3. Okay, 5 here, again, we're going to have substitution because it's y equals negative x minus 6. The steps are going to be the same, so I'm probably not going to be explaining as much. I'm just going to work out. This is negative 1x. Negative 6 is the only thing that's distributing here. So the negative 1x just comes straight down. We don't do anything with it. And I've got positive 24x, that's negative times negative, minus 42, negative times positive equals negative 19. Combine, 23x minus 42 equals negative 19. Add 42, use opposites since I'm moving it across the equal sign, equals 23. Divide, x equals 1. Remember, plug back into where you have circled. That's the easiest place. Negative 4 plus 7 is 3. So my answer here is going to be 1, comma 3. On 6, again, we have substitution, this time in the x spot, negative 8, y minus 3, minus 4y. The negative 8 is only going to distribute to what's inside the parentheses. So negative 8y plus 24. Combine like terms for the things that we have that are on the same side. Negative 12y. Use opposites to move things across the equal sign. Last step, always division. Y is going to equal positive 3. We're going to plug into my original equation, the one that I circled, so 3 minus 3. So x is going to be 0, which is going to make my final answer 0, comma 3 for this ordered pair. All right, 7. Here, because they're both in standard form, we are back to elimination. So we're looking for perfect opposites, and we already have them, which means we don't have to change anything. Those cancel, so we're going to add what's left. That's going to give me 5y equals 5. solve this, so y is 1. Then we want to plug into an original equation. I'm just going to use the top one probably every time. I think a lot of you like to do that. Equals -6. And then we're just solving. Multiply there. 8 times 1 is 8. Now I need to use opposites so that I can get x by itself. So -7x equals -14. Divide. Always our last step. X is 2, so my ordered pair is going to be 2, 1. Remember, you can use a calculator to check that that works. And here we are at our last problem. Again, it's elimination because they're both in standard form, which means the x's and y's are on the same side of the equation. Some of you think about that like everything is all lined up. We don't have perfect opposites here, so we need to make perfect opposites. So however you're going to think about that, I think x's or y's, it makes sense to multiply the bottom by 3. So multiply the bottom by 3, and the top is going to stay the same. You need to rewrite that, so 15x minus 30y. All right, the bottom is going to become -15x plus 30y. Well, I miscopied the top. Equals 15. And now we need to add. Notice that the x's cancel, and the y's cancel, and the 15's cancel. All right, so here we're going to be left with 0, because there's nothing on the left side, equals 0. Again, because your variables disappeared, you have to ask yourself, is this true? Well, does 0 equal 0? Yeah, it does. So this is infinitely many solutions. We're saying that because 0 does equal 0. If you had gotten something like 0 equals 5, then that would have been no solution. That's just kind of a little example for you. Okay, here they want us to solve by graphing, so I'm going to use red to graph my first equation. I need to start at -4, right? Y equals mx plus b, and then my slope right here, 1/2, is rise over run. So from my starting point, I'm going to rise 1 and run 2, rise 1, run 2. I keep that pattern as many times as I can going through my graph. Remember, you have to go backwards also. So the opposite of that would be to go down 1 and backwards 2. Down 1, backwards 2. All right, we want to connect that to make one whole line. And we'll do our second one in blue. So I'm going to start at +3 on my y-axis, and then we want to make my slope a fraction. So that's -3 over 1, which means I want to go down 3 and forward 1. Down 3, forward 1. All right, we keep that pattern going. Remember, the opposite is to go up 3 and backwards 1. As many times as it'll fit, we're going to connect our line. And our answer is the points that they share. So that's this point right here where they're crossing each other. This one has one solution, and we want to name the actual solution. So that is x comma y, right? Remember? So that's 2, -3. That is where these two lines are crossing. You can still use this and plug it into your original equations to check, just like you do with your other problems. All right, x equals -4. That's going to cut through my x-axis at -4. All right, so we'll cut through the x-axis at -4, means it's going to have to go perfectly straight up and down. Now my next equation, cover-up method would be ideal, right? It would be the easiest thing to do if I could cover up my y and solve, or cover up my x and solve. The problem is, if you do that, you get, these are the two problems you get. 3x equals -4, and -2y equals -4. Well, that does not divide well. So we want to use a different method because we don't want to have to graph fractions or decimals. So instead, I'm going to solve this for y. This is something we haven't done in a while, so don't stress too much about it, but try to follow what I'm doing. I want y by itself. So the first thing I need to do is move my 3x over. To do that, I've got to subtract it. Minus 3x. All right, so they're going to cancel. Negative 2y. I want mx plus b, so I'm going to put the x part first and then my y-intercept. All right, now y is almost by itself, but I need to divide negative 2. I need to divide every single piece by negative 2, so I'm going to be left with y equals positive 3 over 2. Remember, negative divided by negative is a positive. Plus, so negative divided by negative, 4 divided by 2 is 2. So this is the equation I'm graphing. So I'm going to start at 2, go my slope right here, the 2/3, my 2/3 slope, says I need to go up 3 halves, up 3 over 2. Fit it as many times as you can on the graph. The other direction is to go down 3 and backwards 2. All right, so we're going to connect all that. And then if we want to write our solution, we're looking for where they cross. And here my answer is negative 4, negative 4. If you have questions, if you need any help with any of those problems, come see me for tutoring in the morning so that you can get help before your test.